All right, grade 8. Today we're getting into graphing proportional relationships. Graphing proportional relationships. And our first set here, when two quantities, x and y, are proportional, the relationship can be represented by the equation y equals mx, where m is the constant of proportionality. All right, so let's talk about that. When two quantities, x and y, are proportional, the relation can be represented by the equation y equals mx. Looks a little bit like slope-intercept form, but there's no plus b, where m is the constant of proportionality, basically meaning there's consistency. We're taking m and we're multiplying it by x, and we're getting y. M is always the same. X may change, which means y is going to change, but they're going to continue to be proportional because m is going to be the constant. M is always going to stay the same. The graph of any line y equals mx, regardless of what these values are, will always pass through the origin on a coordinate plane, which is the ordered pair 0, 0. So if you imagine a coordinate plane, there's my y-axis, there's my x-axis. This point right there is 0, 0. That is the origin. All right, so let's talk about what it is on your assignment that you're going to be doing today. Basically, what you're doing is you're going to be given either a graph or a table, okay? And you're just simply going to be determining yes or no, is it a proportional relationship? Basically meaning, can it fit that equation, y equals mx, okay? And then does it pass, thus meaning it passes through the origin, 0, 0. Now, when I look here at number 1, I'm looking first for some ordered pairs, all right? So I have this point here, all right? That's 0, 1. And then I have this point here, okay, which would be 1, 2. Now already I can look at those. And if m, we're saying that if x is 0, then y is going to be 1. And that's not really going to work, okay? 0, 1. It's not really going to be a proportional relationship. But then if I have 1, 2, and then I see that it's 2, 3, and so forth, and it just kind of keeps going, that's not going to be a proportional relationship because I didn't do the same thing to x every time to get y. And it's always multiplication. I can't take 0 times something and get 1. I could do 1 times 2 and get 2, but then I would have to take 0 times 2, which would give me 0. So that's not going to work. Plus, you see this line. It does not go through the point of origin. Thus, this is a no. When I look at this second one, it's like, well, okay. I see I got some ordered pairs. I got 5, 5. All right, and then I see another one right about there, give or take. And that's going to be 10, 10. And as I start to compare them, I can see, well, this actually makes sense. Because if I go to this y equals mx, I would do 5 times 1 is 5. If x is 5, 5 times 1 is 5. And here if x is 10, y is 10. If I make x 10, it's 10 times 1 equaling 10. And it would go through 0, 0, because if m is 1 and x is 0, 0, if I have the ordered pair, 0, 0, x, which would be 0, times 1, still making this 1, would equal 0. And it goes through that ordered pair. This would be a yes. Now, if it wants an equation when it's yes. So when it's yes, you're supposed to write the equation, not y equals mx, plugging in numbers, okay? So basically, if I'm writing an equation, okay, I'd basically say y equals 1 times x. But I know that I can't put a 1 in an equation, so in front of a variable, whoops, not times. So I'd end up with y equals x. All right, let's look at the next one here. All right, x, when x is 2, y is 8. When x is 4, y is 16. When x is 6, y is 24. When x is 8, y is 32. Well, I go to the first one. I say, well, I always know that it's multiplication. It's always that y equals mx. And I start to see a pattern here. 2 times 4 is 8. 4 times 4 is 16. 6 times 4 is 24. 8 times 4 is 32. I'm always taking x, which is this value up here, and I'm multiplying it by 4. 4 is my constant, and I'm getting the number down here. 2 times 4 is 8. 4 times 4, 16. 6 times 4, 24. 8 times 4, 32. You see the pattern. Now, what would my equation be since this is a yes? Well, it would be y equals 4 times x. And sure enough, this would go through the point of origin, because if x is 0, that point of origin is 0, 0. If x is 0, 4 times 0 is going to give me 0 for y, which is what is there. All right, last one. When x is 3, y is 9, 5, 12, 7, 15, 9, 18, 11, 21. Well, I see with 3 and 9, that's looking for y equals 3 times x. Because 3, if x is 3, 3 times that equals 9. Well, let's see if that's consistent. Because then I would have to do 3 times 5, which is 15, but here it gives me 12. Then I'd have to do 3 times 7, which is 21, but it gives me 15. So I know that this one is a no. Not a real difficult concept today, grade 8. All right, we'll talk to you later. Bye.